Good morning to one and all. Today we will discuss about the topic of deterministic finite automata. The term deterministic refers to the fact that there is only one path for a specific input from current state to the next state. In deterministic finite automata, if you give input a fixed state, it goes to the next state. The deterministic finite automata is also called as a DFA in short form. The name DFA here, the name DFA is means we are giving name to DFA is it consists of 5 tuple notations capital Q, summation, delta, Q naught and F. Capital Q is a set of states. It is nothing but it consists of start state, final state and set of intermediate states also. Next one is summation. Summation nothing but we call it as an alphabet. It is used to store input symbols. These input symbols are used to give input to the machine. And delta is a transition function and Q naught is a start state. F and F is called as accepting state or final state. Here in this diagram we observe that we are having three states Q0, Q1 and Q2 and we are giving two input symbols, those are 0 and 1. In these two input symbols here we are applying these two input symbols to each state. Q0 for Q1 state we are applying 0 and 1, for Q1 state we are applying 0 and 1 and for Q2 state we are applying 0 and 1. So in DFA we have to observe that we are applying input symbols 0 and 1 to each state and we observe that what is final state and what is start state. How we can observe is here before the circle if there is an arrow and you can label it start, then indicate that it is a start state. Whereas to identify final state, if the circle, if there is a double circle, then we indicate that it is a final state. Transition function. The transition function in DFA maps each state and input symbol to a specific state. This means for every state and every input there is exactly one possible next state. If you give input to one state, it goes exactly to the subsequent state. Transition function is usually represented in a form of transition table or transition diagram for clarity. The transition function is written in the form of delta of Q0, 0 equal to 1. In the diagram, we observe that if you give input to 0, input 0 to the Q0 state, it goes to the Q0 state only. So we are writing the transition function as delta of Q0, 0 equal to Q0, delta of Q0, 1 equal to Q1, delta of Q1, 0 equal to Q1. Like that. Suppose if you are giving input to the Q2 state, I am passing input to the Q2 state is 0 and 1. If you give input 0 to the Q2 state, go to Q2 state only, or we can give input to the Q2 state 1, it goes to the Q2 state only. So delta colon Q into summation to Q. Q means it contains set of states. Here in this diagram we are having three states Q0, Q1 and Q2. In alphabet means here we are using two input symbols that are 0 and 1. These 0 and 1 are called as binding alphabets. These are called as binding alphabets. How DFA process string Q0, Q1 and Q2. Q1, Q2, Q2. These are the three states. So using this above DFA diagram, we have to process the string AA, BB. How we can process the string AA, BB? Here we are taking the input string A, BB. First, using this DFA diagram, here we are giving input A to the Q0 state, it goes to the Q1 state. The next input is after A, the next input is B. Now we are giving input B to the Q1 state, it goes to the Q2 state. After B, the next input is B. Next we are giving input to the Q2 state. If you give input B to the Q2 state, it goes to the Q0 state. Here the Q0 is not the final state, it is a start state, and Q1 is the intermediate state, the Q2 is not the final state. So after Q2 is the final state, but Q1 and Q0 is not the final state, because in this after the string is processed, the state is in Q0. So the string is not accepted by the machine. Why? Because here the Q0 is not the final state and Q1 is also not the final state, only Q2 is the final state. If the string after the string is processed, if the state is in Q2 state, then only the string is accepted, otherwise it is not accepted. It is one general example. Another example, if I taking another example, A, B, A, A, B. First, starting with Q0 state, I am applying input B to the Q0 state. It gives the output Q1. Similarly, if I am applying next input B to the Q1 state, it gives the input Q2. Next, I am applying another input A. It gives input. Applying input A to the Q2 state, it gives output Q1. And another input after A is another A, and we are giving another A to Q1 state, use the output Q1, and after A, we are giving another input B. So, if we are applying B to the Q1 state, it goes to the Q2 state. So, after the string A, B is processed, the state is in the Q2 state. This means the string is accepted. Why the string is accepted means after the string is processed, the state is in the final state Q2. So at the end of the string AB, the GFA will be in state Q2, which is the final state. So the string ABB is accepted by the machine. If the string is either in Q0 or Q1, the string is not accepted. The string is accepted only if the state is in Q2 state. Next, what is the difference between transition diagram versus transition table? In transition diagram, here we having the two states Q0, Q1 states, and applying the input symbols 0 and 1. Here Q0 is a start state and Q1 is the acceptance state. In this using this transition diagram, we are drawing the transition table. So we can draw the transition diagram using table, or we can draw the using transition diagram, or we can draw the transition table. First, I am taking the transition diagram and using the transition diagram and drawing the transition table. Here in this table I am taking two columns. Why I am taking two columns means in transition diagram we having inputs only 0 and 1. So I am taking two columns in the transition table 0 and 1. And we have two states in transition diagram Q0 and Q1. So I am taking two rows in the transition table. So the rows we observe that the states are represented in the rows and columns are and input symbols are represented in the columns in the transition table. So in transition table we are taking two columns and two rows. Here for two columns we have taken the input 0 and 1, and for two rows we are taking the input Q0 and Q1. The transition diagram of DFA has two states Q0 and Q1. These two states are represented using two rows Q0 and Q1. There are two input symbols 0 and 1. And these two input symbols are represented in the column in the transition table. In transition diagram, the start state is represented using an arrow marked not originating from any state and labeled start. Whereas in transition table, the start symbol is identified by putting an arrow with direction towards right. In transition diagram, the final states are represented by two circles. Whereas in transition table, the final states are represented by putting star by the side of states. Equivalence of two final state machines. When we say that two states final state machines are equal. So two final state machines are equivalent if and only if they're having same input and same output alphabets. Means if you're giving same input A and B and using same output alphabets A and B, and if starting from the respective initial state they produce same output for any input stream, then only we can say that these two final state machines are equal. Therefore, we can see with an example. Here I am taking two final states. One final state name is Q, another one final state name is Q dash. In Q final state machine, in the first state diagram, we observe that they having three states Q1, Q3, Q2. In second diagram, we observe that we having four states Q4, Q7, Q5 and Q6. So here we are observing that in both diagrams we are using the same input A, C and D, and the start states will be the Q1 and Q2 is the start states, and Q1, Q4 are also the final states. So first we are taking the same. Here equivalence means if the two states are either non-final states or two states are either final states. Here in the diagram we observe that there are two final states Q1 and Q4. These Q1 and Q4 are also the start states because there is a having arrow before circle. So Q1 and Q4 are considered as a final states, or we consider it as a start state also. So we are taking Q1 and Q4. If you are applying Q1 and Q2 to the input symbols, for Q1 applying C, then it goes to Q1. In first diagram, if I am applying C to the Q4 state in the second diagram, it can goes to the input C. So like that. Next one is we have applying the input D. In Q1 we are applying D to the Q1 state, then it can goes to the, so we are applying in Q1 state, we are applying input D to the input D, it can goes to the Q2 state. And in Q4 state, I am applying input D, can goes to the Q2 5. Here Q2 and Q5 both are the non-final states, so those are equal. In first, if you are applying C and D, we can get the output Q1 and Q4. Here Q1 and Q4 are also final state. So when we said that two final states are equal, means if they contain two final states and two non-final states. If one is final and then when another one is non-final, then it is not an equivalent states. Next I am taking the input. We get the output for Q1 and Q4. We can get the states Q2 and Q5. Now we are applying Q2 and Q5 to the input symbol C and D. So for Q2 we are applying the input C, then it goes to the input 3. And if you are applying C to the Q5, it can goes to the Q6. Similarly, for if you apply input to the Q2D. For state Q2, we are applying the input D, then it goes to Q1. And if we are applying D to the Q2 5, it goes to the Q4. Here Q3, Q4 also, so Q3, Q6 are also the non-final states, and Q1, Q4 are the final states. So these two states are equal. And next one is Q3, Q6. Q3, Q6 means for Q3 and Q6, first I am applying the input symbol C. For Q3, I am applying input symbol C, then it goes to Q2. And next I am applying input symbol D to the Q3 state, then it goes to Q3 only. Next I am applying input symbol C to the Q2 6. If we are applying input symbol C to the Q2 6, then it can goes to the Q2. Similarly, if you apply input symbol D to the Q2 6, then it goes to the Q2 6 only. So we observe that Q2 and Q2 7. These two are the non-final states, so these two are accepted. And similarly, Q3 and Q2 6 are also the non-final states, and these two are accepted. So these two are equivalent states. And again, in these two outputs here, Q3, Q6 are already applied, and the remaining one is Q2 and Q7. These Q2 and Q7 are applied. For in Q2, we are applying the input C. In diagram, we can see that if you apply input C to the Q2 state, then it can go to the Q3. Next, and if you apply input C to the Q7, then it can go to the Q6. Here Q3 and Q6 are also the non-final states. So these two states are accepted. Then we apply the another input symbol D to the Q10 and Q7 state. If we apply input D to the Q2 state, then it can goes to the Q3. Sorry, if you apply D to the Q2 state, then it can go to the Q1 state. And if you apply D to the Q2 7, then it go to the Q4 state. So here Q1 and Q4 are also the final step. We get the output for T, and for output C we get the output for Q3 and Q6. So by applying all these, we can see that there is no state in Q and Q dash state where one state is final and another state is not final. These two DFAs are equivalent. And if any one state is final, another state is not final, then these two DFAs are not equal. So DFA means here deterministic finite automata means here the main important point in DFA is if you take two input symbols, the two input symbols are applied to each state in the DFA diagram. If you have 3 states, then you have to apply the input symbols to 3 states, which is very most important point in the DFA. So I am repeating once again how DFA process C. Here I am taking the input transition diagram. I am taking the input string is A, B, A, A, B. For first I am taking the input P. I am applying input A to the start state Q0. It can goes to the state Q1. Then we are getting the output Q1. After getting output Q1, I am applying another input B to the Q1 state. Then it can goes to Q2 state. Next we can get the output Q2 state. Later after applying after input string B, then I am applying the input A to the Q2 state. Then we can get the Q1 state. Then after A we having another input A. So I am applying A to the Q1 state. Then we can get the Q1 state output again. And after we having another input B, then I am applying B to the Q1 state. Then if we apply B to the Q1 state, we get the output Q2. So after the string ABAAB is processed, the state is in Q2. Is at the end of the string ABAAB, the DFA will be in state Q0, which is the final state. So the string ABAAB accepted by the machine. Otherwise, if the string is not in Q2, if it is in either Q0 or Q1, the string is not accepted. So compulsory, if the string wants to accept it, the string must be in the final state only. After the string is processed, the string will be in the final state only. So I am taking another example ABB. So I am taking here the three input string, that is three letters of input string, that is ABB. So first I am applying input A to the Q0 state, it can go to the Q1. Next I am applying input B to the Q1 state, it can go to the Q2. And later after the input string B, we having another letter B. I am applying B to the Q2 state, then it can go to the Q0. So in the first diagram and in the second uh, the first example and in the second example, we observe that in the first example, the string after the string is processed, the state is in Q2, which is the final state, so the string is accepted. But in second example, after the string ABBC is processed, the string is not in the final state; it is in the start state or it is in the intermediate state. So it is not in the final state. So at the end of the string ABB, the DFA will be in state Q0, which is not the final state. So the string ABB is rejected by the machine. So transition diagram versus transition table. In transition diagram, we are taking the states as circle, representing states as a circle and giving input 0 and 1. Another important point is if the state is having for loop, it means that there is no change in the state. It will remain in the same state only. So depending on transition diagram, we can draw the transition table. In transition diagram, we have in two states. So we are taking two rows in the transition table. In transition diagram, if we are having three states, we can take three rows in the transition table. And in transition diagram, we observe that we having two input symbols 0 and 1. So I am taking two columns 0 and 1 in the transition table. Here in transition table, the rows are represented in the rows represented by the states, represented by the rows, and input symbols are represented by the columns. In transition, the start state is represented using an arrow mark not originating from any state and label state. The start state is identified by putting an arrow with direction towards right. The final states are represented by two circles, whereas in transition table, the final states are represented by putting star by the side of start states. Equivalence of two finite state machines. Two finite state machines are equivalent. Means if they're having same input and same input alphabets and same output alphabets starting from their respective initial stage, and they produce the same output for any input string. They produce same output for any input string, then we can say that these two states are equal. Here we observe that we are taking two finite state machines Q and Q dash. In this Q and Q dash, first I am taking the starts here. In these two diagrams, the start state is Q1 and Q2, and these two are also the final states Q1. First, we are applying for Q1 and Q4. I am applying the input C and D. We get the output Q1 and Q4 for input symbol C, and for input symbol D, we get the output Q10 and Q5. So already Q1 and Q4 are the final states. These are the equivalent states. And Q2, and we observe that in output we get Q10 and Q5. And these Q2 and Q5 are the non-final states. So these two are also the equivalent. So already we apply Q1 and Q4. And the remaining state is Q2 and Q5 is not applied. So I am taking those states. Q1, Q2 and Q4 are applying the inputs C and D. When I apply input symbol C to the Q2 and Q2 file, I get the output Q3 and Q2. Similarly, if I apply input D to the Q2 and Q2 file states, I get the output Q1 and Q4. So, Q1 and Q4 already, these two are the final states. Next, we will check whether the Q3 and Q26 are the final states or the equivalent states or not. Here, in this diagram, we observe that Q3 and Q6 are also equivalent states because these two are the non-final states. So now we apply Q3, Q6 to the, taking Q3, Q6 and we are applying input symbols C and D. For Q3 and Q6, we are applying input symbol C, then we get the output Q2 and Q7. For input D, we get the output Q3 and Q6. So Q2, Q6 already gives us the equivalent states. Now we check whether Q2 and Q7 are equivalent or not. In this diagram, we observe that Q2 and Q7 are also equivalent states because these two are the non-final states. Next, we are applying the input Q2 and Q7. In Q2 and Q7, we are applying the input C. Then we get the output Q3 and Q6. And for Q2 and Q7, we are applying the input D. Then we can get the output Q1 and Q4. So there is no state in Q and Q1 pair where one state is final, another state is non-final. So these two DFAs are equivalent. Thank you, one and all.